Hello and welcome to Space Time with Robert. My name is Robert, and let's go over the Apertura AD10 Dobsonian. That's our cat, Ted. When pointing straight up, the telescope is about 4.5 feet tall and roughly 2 feet in diameter. It's a big telescope and the base itself is over 2 feet tall, so storing it can be a bit of an issue. And keeping it like this in the snow is not a good idea. The optical tube is 1 foot in diameter, or just over 300 millimeters, and is over 4 feet in length. I would have bought a bigger telescope, but this was the biggest I could fit in my car. Also, weighing less than 80 pounds totally assembled, it is a good match for how much I can carry comfortably. And this is how I store it when I travel. Back to storage, showers can be an awful place to store it. Behind doors, under your pillow, or in the barbecue are more terrible places to store it. Storing it outdoors temporarily like this, it's okay. This is an outdoor closet. But ideally, I like to keep it indoors and tilted, like this. This prevents dust from landing on the mirrors over time. Now let's break it down. Starting from the ground up, we'll go over the mount first. I'll take this base apart so you can see how it works. First, I will remove the tension knob. And that's not good. Our tension knob broke. It broke due to over-tightening, so your knob and bolt should still be glued together. Next is the small washer. Then, there's a bearing. After the bearings, there's a large washer. Now, the whole entire base can be separated. This reveals a metal sheath that can be removed. It prevents the threads from chewing at the wood, I think, and now I can remove the top metal disc. Under that should be our Lazy Susan bearings. This is the magic, this is how it all works right here. They work the same either way. And here's how it works. When I put these two metal plates together, sandwiching the roller bearings, the top one is going to rotate freely, while the bottom one stays still due to friction. Tightening the knob on top makes it harder for the entire base to rotate. As you can see, there is some wear on this thing after tightening it so much and lots of use. And it's normal for it to look like that, and it's okay, it'll last a long time. I'm going to inspect the underside now, and here you can see that there are 3 feet that the base will balance on. This is your tripod, basically, and here's a tripod foot. It's the tiniest little tripod. Okay, but these work well, and they seem to last. And also, I need to make sure that this center bolt here is flush with the base, and so you need to do that as well if you're ever inspecting the bottom part. And that's only if your knob is broken off. Okay, let's put it back together. First, I'll put the axle sleeve on, and I can just do that now, why not? Then I'm gonna put a metal disc, the same one that's all worn out. After that, I'm gonna put the roller bearings on. And then another metal disc. Next, I'll carefully position the upper base plate, trying to put it gently over the center bolt, perfect, just like that. Then I put the large washer on, bearings, then a small washer, and finally the broken tension knob. Again, our knob broke off due to over-tightening. Your knob and bolt should still be glued together. You can super glue the knob and bolt back together if you wish, but we found it still works fine actually. Now you know how to take the mount apart and put it back together and clean it should it need any maintenance. Okay, moving on up, let's go over the optical tube assembly. Again, I'll name all the components and explain everything I can. First, we have the focuser. This will make things blurrier or less blurry. Next, the viewfinder, which helps us aim the telescope, along with this Telrad, which we later added on. There are also balancing knobs on either side of the telescope, and lastly you have a fan in the back which will help with acclimation. The most important things are the mirrors. How it works is light enters the front end of the telescope, bounces off that back mirror, reflects off a smaller angled mirror inside, and then gets funneled out the side into your eye, essentially giving you a bigger, better eye. The fan we mentioned helps keeps those mirrors acclimated, reducing distortions caused by heat. To turn it on, we use a 12-volt DC battery. There is no switch or speed controller. Typically, I will let it run all night long to help regulate the temperature as it drops. To turn the fan off, simply disconnect the power cord. And here's the battery that we were using. Just make sure that you are using a 12-volt DC power supply. Now let's go over the focuser and its components. Again, the focuser is meant to make objects appear blurrier or less blurry, but you want them to be mostly less blurry. The lower screw locks the focuser in place so that it can't move anymore. Once it's tightened, it's locked. Loosen the screw to unlock it. The upper screw controls the focuser's grip. If it's too loose, this will happen. So keep it a little tight, so that way the focuser is able to move up and down just by turning the knob. This small focus knob is meant for fine adjustments and is good for planets when you are at high magnification. The small cap is to help prevent dust from getting in. To remove it, just loosen the screw nearest to it. Then, pluck it out. How it clamps is by that screw pressing on an inner ring to hold eyepieces. And it's the same for the next two screws behind this one. To remove the 1¼ adapter, just loosen both of those screws, then pluck it out, just like the dust cap. And again, this larger eyepiece holder also has an inner ring. To add the 1¼ adapter, insert it into the 2-inch holder. Then, evenly tighten the two screws to hold it in place. I'll often test it to make sure it's not going to fall out. Then replace the dust cap the same way. Try not to over-tighten the 1¼ screw, or any screw, and yeah, onward and upward. Now let's go over the balancing knobs on either side of the telescope. To adjust them, I will first loosen the two Allen bolts. Now that they are loose, I can reposition the knob. After repositioning, tighten both knobs evenly. Why would we want to do this? It's to adjust the balance of the telescope, if the telescope were too front-heavy, for example. After tightening, I like to make sure it's still secure. Next, before making the same adjustment on the other side of the telescope, we'll note the placement of the knob using these marks. I'm noting 3 ticks right of the 0. So now I'll make the same adjustment on the other side of the telescope. Again, starting by loosening the bolts. Then I move it to the position that I noted on the other side. For this adjustment, I like to be as precise as I can. Now I've aligned both knobs to the same spot. Lastly, I like to make sure to retighten the bolts evenly, doing my best not to move this tension knob at all. If you do not tighten the knobs evenly, then your telescope will not rest on the mount properly. So you want to make sure that all of this is very square and aligned. When placing the telescope on the mount, try and make sure that the flat parts of the knobs are pointing up, while the curved parts go into the matching cutouts on the base. And then once placed, just twist the knobs to apply tension. Next, let's go over the secondary mirror. Not the mirror in the back, but this little one here to the left. Here's another look at it from inside the focuser. You can see that it's oval in shape, and It's probably important that this thing is well centered. For adjusting the tilt of this mirror, we have 3 collimation screws behind it. For translating the position of the mirror within the optical tube assembly, first you have a center screw which adjusts how far the mirror is into the telescope, while also allowing you to rotate it entirely. Then there are 4 support beams for adjusting the lateral position of the secondary mirror within the telescope. These also give bright objects seen through the telescope those 4 distinct spikes that you're used to seeing in astrophotos. For attaching the Telrad, we'll use masking tape for the base. Masking tape will help preserve the signatures that are on the telescope. We'll also use a Velcro strip for added safety. Once the base is securely attached where you want it, place the Telrad with its 4-inch riser onto the base, making sure that the switch is towards the primary mirror. Then secure it with the 2 bolts. The Telrad is entirely optional, but we found it to be helpful for aiming at things faster. For even more precise aiming, we'll use the stock finder scope. It fits into the finder's shoe near the focuser. After placing it with the lens facing forward, secure it using this thumb screw. Make sure it's tight and it won't fall out when you let go. Also, don't forget to remove the dust caps before you use it. And don't forget to put them back on when you're done. To remove the viewfinder, first grab onto it, then start loosening the thumb screw and slide it backwards. The 2 screws on either side of the viewfinder adjust its tilt. The top one is for tilting it up and down, while the side ones will adjust its horizontal tilt. Lastly, there is a spring tensioner near the focuser. Only tighten it if it ever gets loose. You may also have a 35mm extension tube that came with your telescope, and we actually never used this. But how you use it is by first loosening the 2 thumb screws that hold the 1.25" adapter in place and plucking it out. Then insert the 35mm extension tube and secure it in place with the 2 thumb screws. I like to apply even pressure on both the thumb screws to make sure it's centered. And that's it. The manual suggests using it for focusing the 30mm 2-inch eyepiece, but we've never been able to get that to work. Instead, we just pull the 30mm out a little bit so that it can get to focus. Let me know if we're missing something. Here is the 9mm eyepiece that comes with the telescope. We use it as a backup for close-up views. Its main issue is how small the field of view is. You have to get your eye really close to see anything as well. It inserts into the 1.25" adapter and it magnifies roughly 139 times. Another eyepiece that comes with this telescope is the 2-inch 30mm SuperView. This eyepiece is great for galaxies and star clusters and will give you a very wide-angle view. To insert the 2-inch 30mm eyepiece, first remove the 1.25" adapter, then insert the 30mm eyepiece. You may think it's best to insert it all the way, just like this, but a problem we kept running into was we were not able to achieve focus with the eyepiece like this, even if we racked the focuser all the way out. So a trick we found was to pull the eyepiece out just a little bit like this, making sure the eyepiece is still secure, and now we can achieve focus very easily. And that's how we use this eyepiece. Here is a zoom lens that we like to include with our donation kits. You can insert this zoom lens into the 1.25" adapter and then secure it by twisting the compression screw. Try not to over-tighten. Then you can twist the eyepiece to zoom in or out. It ranges from 7 to 21mm in focal length. Here's a simulation of the magnifications possible. Other than the SuperView, we really only used this one eyepiece. If you wanted to zoom in even closer, we also supplied a Barlow lens. Here's what it looks like in the telescope. And you can use it with any 1.25" eyepiece. To use the Barlow lens, first loosen the thumb screw. Then remove the dust caps. Now, insert the Barlow into the focuser using the 1¼ adapter. Then insert the 1¼ eyepiece into the Barlow lens and secure it using the thumb screw. A ×2 Barlow lens will divide the focal length of the eyepiece by 2, essentially converting this eyepiece into a 3.5 to 10.5 millimeter zoom. And here is a simulation we made of the moon using a zoom lens with and without a Barlow lens. Barlow lens often also make the views darker. And for this reason, Barlow lenses are best on bright objects, like our moon or the planets. Another accessory we included was the variable lunar filter. If things are ever too bright, you can always use this. This one adjusts the brightness of your view. It's like putting polarizing sunglasses on your telescope. These are especially useful for Venus and the moon. Great for when objects are too bright to see details. And no, you cannot use these to look at the sun. And please remember, don't ever aim your telescope at the sun without a solar filter. If you do, the sun will likely make you go blind and your hair will catch on fire and no one will like you anymore. I'm kidding about the last part, but really don't do it. To attach the filter, first look for the threaded side. Next, thread the filter onto the bottom of any 1¼ eyepiece. Make sure it's fully threaded onto the eyepiece. Once secured, you can twist the lower portion and this will adjust the brightness. I like to adjust the brightness before putting the eyepiece into the telescope. Now, we are ready to put the eyepiece back into the focuser and secure it like regular. Okay, let's go over collimating the mirrors now. Here's a diagram showing the primary and secondary mirrors. And here's the telescope's tube that holds those mirrors. The primary mirror squishes light into the shape of a cone, while the secondary mirror angles that cone into your eye. If the primary mirror is misaligned, then you're going to see things blurry no matter how much you try and focus the telescope. And the same goes for the secondary mirror. So, how are we going to align these mirrors with each other? Introducing the 1¼ Laser Collimator. It fits into the 1¼ eyepiece adapter on your focuser. Try to have that target facing the back, and try to have the focuser fully racked in. This will help us collimate the primary mirror more accurately. Here's how the collimator works. First, we'll place it into the focuser with the opening towards the primary mirror. Then, while racked all the way in, we'll turn it on and increase the brightness until we see the laser. Once the laser is turned on, it should bounce off the secondary mirror, travel down the tube, bounce off the primary mirror, traveling back the way it came. Then the beam should bounce off the secondary mirror again and then back into the collimator, landing on the target. If the primary mirror is off in any way, then the laser will miss the center of the target on the collimator. If the secondary mirror is off, then the laser will be outside of the circle on your primary mirror. Okay, let's collimate. First, grab the collimator. Next, insert it into the focuser while the focuser is fully racked in. And rotate the target towards the primary mirror. Then clamp it down just like an eyepiece. And turn it on. Again, try to have the focuser fully in and not focused out. We'll collimate the secondary mirror first. You should see 3 screw heads that bump out. They are highlighted in green here. We'll adjust these 3 until the laser is within the small circle on the primary mirror. I like to start by loosening one bolt and then tightening another. Usually you only need to adjust 2 bolts. And we'll use a crosshead Phillips screwdriver to turn them. Okay, so let's grab a screwdriver. If the laser isn't in the circle on the primary mirror, start by loosening one of the bolts. I'll pick one at random and oops, I just started to tighten that bolt first on accident. All that did was just jerk the mirror around. So I'll start again by loosening a bolt this time and seeing where the laser goes. Now I'll tighten a different bolt. and there is a nicely collimated secondary mirror. For the primary mirror, first loosen the white knobs. These hold the mirror in place so you don't lose your collimation. Next, adjust the black knobs until the laser hits the center of the collimator. Then tighten the white knobs evenly, and you may notice that the laser moves off center as you secure the mirror here. Just turn each knob the same amount, and it should center itself again. Practice this indoors to get the hang of it. And that's all for basic collimation. Would you like to know more? Search Astro Baby Collimation. Okay, let's go over balancing the telescope now. With all the accessories attached, you may notice that the telescope is a bit imbalanced. Here it's a little bit top-heavy. Every time you let go of the telescope, it drifts either up or down. A quick solution to this problem is to simply tighten the altitude bearings, but try not to over-tighten the bearings, and if it's still slipping after you've tightened them, then it's time for another solution. And that would be to add a counterweight to the telescope. We supplied a yellow magnetic flashlight to your donation kit for this purpose. You can attach it like this anywhere you need for better balancing. Your last option is to adjust the position of the altitude bearings. Just make sure that they are parallel with each other once you do this. A convenient tool for moving the telescope around is a hand cart of any kind. This one is mostly made out of plastic and it folds up. We've been using this one for 6 years and it still works great. Before aiming the telescope at something, it's good to align the viewfinder. Start by aiming the telescope at something far away and stationary. Like what is that? What is that thing? Like a bird's nest, yes. And for quicker alignment, we'll use the 30mm eyepiece. Center the object in the eyepiece. Then look through the viewfinder and note how off it is. Use the adjustment screws to center the object in the viewfinder. Remember, this right screw will adjust the viewfinder left and right. There it is. And then this top screw is going to adjust the viewfinder up and down. So we just want the crosshairs to be directly on that bird's nest. Once the object is centered in both the viewfinder and the telescope, alignment is complete. Okay, now we'll go over aligning the Telrad if you happen to be using it. First, if you happen to be using it during the day, try not to let sun shine directly onto the lens, because this could burn the reticle. So it is sensitive during daytime. I only use it at night. I find it useful first, though, to align the viewfinder just like we did previously. Then I aim the telescope at a bright star. Then I turn on the Telrad. It can sometimes be hard to see the star when you're at full power, so I like to dial it back and dim those rings a little bit. Now I just need to reposition the bullseye over the star with the 3 white adjustment screws. You may have to play around to find out which screws need adjusting, just like collimating. Almost. We're almost there. Let's see if this fixes it. Bullseye. That is an aligned Telrad. Now you should have both viewfinders aligned with the telescope. You don't have to align your viewfinder first, but I do find it helpful to do that. However, you could always align your Telrad first and then the viewfinder second. I like using the Telrad to quickly aim the telescope at objects, and then I'll use the viewfinder to dial it in even further. That way it immediately shows up in the eyepiece. Also, don't forget to turn off the Telrad when you're all done. Cool telescope. It's good to let your telescope acclimate to the outside temperature before use. Otherwise, the heat inside could cause a mirage-like effect to your views. I would try and let Carl cool down for 30 minutes to an hour before use. You could also use the fan to speed this up if you're in a hurry. Okay, now we'll practice setting up outside. First, I'll put the optical tube on the base, making sure that the flat parts are face up Then I'll attach any accessories I plan to use, like the Telrad, or the right angle correct image finder, also known as the viewfinder. Then I'm going to test the balance of the telescope, and I'm going to make any necessary adjustments to the balance if I need to. Once it's assembled, I like to let it acclimate outside in a shaded area. If I'm in a hurry, I'll use the fan to acclimate the telescope faster. Ideally, I would like to set the telescope up exactly where I plan to use it. However, if I have to move it, I'll use a handcart. Once the telescope is in position, I'll remove all the dust caps and store them somewhere safe. Next, I'll collimate the telescope. First, I'll insert the collimator and rotate it towards the back and turn it on. At the front, I will use the screwdriver to adjust the 3 collimation screws. My goal is to get the red dot centered on the primary mirror. It's pretty close, so we only need to make a tiny adjustment. So I start by adjusting a random collimation screw. It's too tight to adjust, so I will loosen the screw instead to give me some slack. I ensure the screwdriver is well connected so I don't cause damage. Then I loosen a collimation screw and tighten a different one, trying to get the laser on the center. Now that one is loose, so I'll tighten a different screw now. And oh, look at that, that's nice. Nice and centered. No loose screws either. On to the primary mirror. First, I loosen the white knobs. Then I adjust the black knobs while watching the collimator. I'm trying to make the red dot disappear in the center of the collimator. Perfect. Now I tighten the white knobs as evenly as possible. I don't want to over-tighten, as that could pinch the mirror. Once the white knobs are no longer loose, collimation is complete. Then I turn off the collimator before putting it back. Next, I like to align my viewfinders, so I'll grab the zoom lens, and it goes into the focuser. Which way the logo is facing doesn't really matter. I secure the eyepiece and remove the dust cap. Now I'll point the telescope at a bright stationary light source. And I ensure that the crosshairs are on that light. Perfect. Bright lights should show up well in the telescope. Now I'll look into the eyepiece for that light. Since it's a bright light, I can see a glare even though it's not perfectly centered. So while looking through the telescope, I'm going to aim it at that light source. There it is. Next, I will adjust the viewfinder so I can get the crosshairs centered on that light. And let's adjust that now. As I adjust the alignment screws, I'm making sure not to move the telescope. Now that the viewfinder and the telescope are aligned, I can confirm with another nearby light. So I just aim the telescope at another light and then make sure that they're both in the viewfinder and the eyepiece. Perfect, we are good to go. Once the viewfinder is aligned, I'll align the Telrad if I'm using it. And I'll use either a light or a star to do this. With everything aligned and collimated, it's time to look at space. Tonight, I will begin by aiming the telescope at the brightest star that I can see. Okay, I see the bright star in the viewfinder. Now I will focus on that star using the telescope. Oh, that's no star. Okay, hang on. Let me show you what I just found. If you hold your phone to the eyepiece, you can record videos or images of what you've seen and then share them with others. Finding the exact position, though, can be tricky. Okay, here it is. And that looks like planet Jupiter to me. I see Jupiter in the center with 4 moons nearby. 2 on either side. The Galilean moons, these are Callisto, Ganymede, Io, and Europa. And now you can just relax and enjoy the views. But wait, there's more! Do you notice how I'm standing hunched over? There are many solutions to this problem, but my favorite is a chair. There are fancy astronomy chairs that can adjust in height, but this is a foldable chair and it's decent for my size. Although I am still slightly hunched over, I am much more comfortable and I'm not wearing out my legs or lower back by doing this. When you're all done using the telescope, remember to put the dust caps back on all your lenses. However, if it's still wet from the outside dew, try and take it inside so it can dry out first, and then put on the dust caps, so that way you can prevent mold. And that's it. Thank you for watching. You should know everything about this telescope now, and I hope this tutorial has helped you enjoy it a little bit more. The end.